Hello, it's James from XRobots.co.uk. This is part 36 of my Iron Man Age of Ultron inspired Hulkbuster suit. And I've got the torso here, and I had to take it off its legs last time so I could reach the helmet to work on it. So last time I built a bit of a mechanism for the helmet, and I thermoformed some foam and other materials to make curved pieces which are going to make up the helmet, and that helmet is going to flip up and open just like it does in the movie. So this time we're going to continue working on that, but only a little bit. And then we're going to work on how we're going to control the suit with a smartphone. So lots of the features like the pop-up shoulder pods and weapons in the arm, as well as the mechatronic arms, which are mechatronic from the elbow down, normally controlled by joysticks in the upper arm. All those features are going to be controlled with a smartphone app and a web app over Wi-Fi. So we're going to look at that in the second half of the video. But first of all, let's have a closer look at what we did last time. As you can probably see, my t-shirt this week is E.T. the Extraterrestrial. Last time I formed up various sheets of plastic. I formed some in foam and some in 1.5mm styrene, and I formed this one in foam PVC board, which is 3mm, to make the faceplate. Now this is all going to be fixed onto this 3D printed mechanism. So we've got the main helmet here, which can lift up backwards. And I had some levers on the back which are going to be counter-sprung with springs or bungees to take the weight off. And within that I've got this piece which brings the faceplate forward. So the transformation will be something like this. And that will bring the faceplate down that I just showed you. And that hopefully is going to slide up inside the helmet. So when it's retracted, we see something looking like this. So today I'm going to try and fix this faceplate on. It needs cutting down a bit so it fits inside, and then we're going to probably put the eyes in, which will light up, and I'm going to paint this up and put some features on. Then we'll have a look at the smartphone control. I've cut a bit off each side of the helmet, just this piece and a piece on the opposite side. So now the helmet actually, faceplate at least, fits inside the rest of the helmet properly and can fold back without catching its corners. So I need to put a bit of foam or something in there. But basically that's going to work quite well. I think it needs to come forward a bit further so it actually looks down slightly, but somewhere there, and sort of the rim of the helmet gets higher at the back, because that's how it seems to be in the movie. So this whole thing can fold back, and of course this can fold up. And as I mentioned last time, I'll have the little jaw pieces that fold in each side, and they'll be fixed onto servos mounted on this main bracket. So now I've got the main shape for the faceplate, and of course some of that's going to be covered at the sides by the rest of the helmet. I can actually paint this up. We're going to work on cutting the eyes out and deciding how to make the light up eyes and some of the other features. So I've cut out the eyes there, and I've marked some other lines which need to have some markings on, which I think I'm going to score with a soldering iron because this stuff melts pretty easily. But I've also done is an extra cut just here so that I can recess that to make a step so that the brow hangs over the nose there. So something like that. So I just need to glue that on the back with another bit of spare foam PVC board. So I've put that little step in there, and I've just glued a little piece to the back using super glue, which is also known as crazy glue in the US. It sticks foam PVC board really well. So having done some tests, like this piece, I've actually just used this, which is a point, to go and mark that piece, and I think I'm going to do that to the rest. Mainly because I can't find my mucky soldering iron bit I use for melting things. So I'm just going to use something cold, and that seems to work quite well. So those lines will be this feature and the two lines down the side of the head. And I've put this faceplate back on the dome that I used to form it so that I've actually got something to press on rather than trying to do it flat on the table. So this should work pretty well. Just going to do it freehand over the lines I've marked. Can always go over it multiple times. So I've cleaned that up and thrown a bit of grey primer at it, and it's looking not too bad. Those lines are quite sharp and they've got quite good contrast. So we're going to throw a bit of gold paint at it out of a rattle can, and then a bit of metallic gold out of an airbrush just to spruce it up a bit. I'll probably come back and do some weathering and things later, but for now we're just going to make it gold and get it mounted. Here it is, all painted up, so we've got the gold on there, quite happy with that, it's quite shiny and glossy. And on the inside I've stuck these tabs, which have got 2 holes in, and they fit onto some corresponding parts which I've just printed, which fit onto the kind of jaw bar, so they will slot in. They're quite a tight fit. It does mean that I can remove the faceplate to work on it, and I can also just adjust this angle slightly and trim it up to get it perfectly right as I build the rest of the helmet. Here we go, so I've clipped that on. It needs a bit of fine adjustment, but eventually that will be glued on. So that just misses the top of the band there, and the faceplate retracts right into the back of the helmet, and that should fit right behind my head. In fact, let's have a look. Yeah, plenty of space for my actual head to fit in there, so that seems to work quite well. And it will face down slightly, and obviously the rest of the helmet will come up with the widow's peak and the pieces around the side and so on. I'm going to install some lenses in the eyes, which are made of 2 parts in each half. The top half here is actually a transparent piece, or at least it'll be printed in a transparent ABS, which is actually going to turn out to be quite diffused. And then a back piece which is going to be white ABS. And you can see there's 5 holes there which are for Neopixels to poke through, which are individually addressable RGB LEDs. Hulkbuster's eyes are white, but it'd be quite good to have them turn red in other colours, the same as the Unibeam. So I'm going to use RGB LEDs there, and hopefully the slope that I've got inside there should diffuse that light quite nicely onto the clear diffuser lens instead of making spots. So we'll see how well that works, but that's what I'm going to do for now. Of course, I'm not actually going to look through these eyes because they're too wide for my own eyes, and they're actually well above my own eyes. So in this case, I don't have to worry about making the lenses see-through, they just need to light up in a nice diffused way. Here are the parts, and I've got the lenses fitted in there, and I've glued in some Neopixels, 5 on each, which I'm just about to wire up, and then we'll stick those into the faceplate and give them a test. I've wired those Neopixels in, and I've connected an Arduino that I've got just here, and I've written a little sketch that fades them up and fades them down when I plug in pin 4 to ground. So if I unplug it, you can see them fading off, and if I plug it back in again, fades up again. But how am I going to make that smartphone controlled? Well, actually I've already done it. So I've got my smartphone app here, and if I click on this button, eyes come on, and if I click on it again, off they go. And the intention is that I can make all of the functions smartphone controlled, including the eyes, including the shoulder weapons, the mechatronic arms from the elbow down, which is one of the reasons I made them mechatronic, the hand grippers and everything else. And as well as just being smartphone control over Wi-Fi, it actually works over the internet. And the board I'm actually using to control that is right here, and that is a particle.io Photon. So let's have a closer look. So here's the particle.io website, and the URL is literally particle.io. The company's formerly known as Spark.io, but they renamed because there's quite a few other things called Spark, including Spark Fun Electronics, SunSpark Workstations, various other things. So they're totally a different company now. They're called particle.io. So they've got various products. If we have a look in their store, we've got the Photon there, which is the one I've got, which is a Wi-Fi connected chip. That's only $19. The Electron, which is for 3G, and there's a whole bunch of other products. So they've got sort of boards these slot into. There's an internet button, which basically is a sort of touch sensitive button that the thing slots into, and various other modules and shields, if you like, a relay shield and various other things you can slot these boards into. And the boards are actually compatible with Arduino code, so it uses the same language. So if you can program an Arduino, then you can actually program one of these, and it's very easy. Documentation lives on this little menu on the right hand side, which you click on, and documentation's really good actually, so worth a look. You can develop your own custom apps using JavaScript, or using the mobile SDK, or just a simple web page, and we're going to do some of that shortly. The Photon comes in a development kit, or it comes just on its own, and I've got the one that just comes on its own, which comes in this little matchbox version, and I've already plugged that into some breadboard. Now I've already done the initial setup, but I'm just going to connect that to power, just with a USB boost adapter, and we should find that it boots up. And I've already gone through the initial setup to connect this to my Wi-Fi, so the green light there is looking for the Wi-Fi. So I had to go and wave that nearer my Wi-Fi router, which is a couple of floors down. And now that's connected, and we've got this blue flashing light, or fading light on there. If I open up the smartphone app, which is called Tinker, and you can install on iPhone or Android. If I just go back a screen, we should be able to see the actual chip there, which says it's online. And basically the pinouts here represent the actual pins of the chip, and D7 has another LED connected, and I've set that for digital write. So if I go and click on that, I can turn that extra LED on that's on the side there. There we go, so that's it in its basic form. And of course we can control any of the other digital pins. So I've just put another LED and a resistor on D6, and if I go and click on the app, we can turn that LED on as well as D7. And of course we can do any digital read and write to those pins, as well as analog read and write. So we can check a switch status, or we can monitor the temperature in our house. And of course this is all I was doing to turn on and off Hulkbuster's eyes. And what's actually happening when I'm talking to my Photon with my smartphone is, in fact, they're both talking to the internet. So they're both talking to Particle's cloud. So my smartphone is actually sending data to the cloud through my Wi-Fi router out onto the internet, and every so often the Photon is also connecting and polling the cloud. So that means that this works anywhere on the internet, and I don't have to punch a hole in my firewall and tunnel into my house, which could be a security issue. So basically they both make outbound connections from wherever they are. So I could go to Australia with my smartphone and I could still turn the LED on and off. Or I could connect two of these modules together, and I could monitor the temperature in an office in Australia and have it turn on an LED on one of these sat on my desk in the UK, or any other combination. And you can also write web apps and all sorts of things. So to show off the web-connected nature of the Photon, I'm going to show you Particle Build, which is basically a web-based programming environment for the Photon chip. This is actually based on the particle.io website, build.particle.io, and you can actually write code in here in a web browser and then flash your Photon wherever it is on the internet. So of course there are some security features. So basically when you set one of these chips up, you claim it in your account and no one else can flash it. The only way to reset it is to press a physical button on the actual device. You've got free programming stuff here. You can type in what you want, same as an Arduino. There's some stock examples, including blinking LED. We've got a web connected LED, so we can make a web page to turn that LED on and off. We've got the publish and subscribe, which are the examples of basically being able to publish data to the web or to another Photon, and being able to subscribe to events. So as I described, having two of those connected on opposite sides of the world. And Tinker is back to the stock example of the app with turning the pins on and off. And of course you can integrate this code into your own apps as well. So first of all, I'm just going to simply get the flashing and LED code, and I'm going to go and flash that onto my Photon. I do that just by clicking on the flash icon on the top left. So my Photon is just connected to power. The other end of this USB cable is just connected to one of these USB boost adapters, so it's not connected to my laptop. The only way it's connected is out of the router to the Wi-Fi, through to the cloud, to Particle's cloud. My laptop similarly is connected to the Wi-Fi, and that's the only way these devices talk to each other, through the cloud. So I'm going to click on the flash icon, and we should see shortly, hopefully you can see that changing purple, and it downloading the code. I think the next thing is it reboots and reconnects to the Wi-Fi. There it goes, and now hopefully you can see that LED flashing away if I move that resistor. So that is the equivalent of Arduino blink, causing it to blink. Of course the other app doesn't work now for Tinker, but if I go back onto my screen, which is over here, and I select the Tinker example, and then go and flash that again, should be able to see in a short space of time. Yep, there it goes again. Reflashing the code. Rebooting. and going back into tinker mode. So if we're lucky, I should be able to go and configure that pin. Oh, there we go, already configured for digital write, so there we go, I can turn that on and off, and the same with D6, back to how it was. You can of course use other devices other than LEDs, and there's some Arduino style libraries which are in particle build, so you can use Neopixels and devices that communicate over I2C among many others, UART serial for instance, and other things. So you could use the Photon for your whole brains for your projects and just look at it like a fairly reasonably priced Wi-Fi connected Arduino. As it is, I've got quite a lot of other Arduinos spread around my Hulkbuster, so I'm just going to use this for Wi-Fi connectivity, and I could of course just use the Tinker app and turn on individual pins to activate functions. What I'd really like to do is write a proper app, or at least something that looks nice, that runs on my phone or a tablet or a web browser of any sort, which is basically a picture of Hulkbuster, so I can click on its eyes and they'll turn on and off, and I can click on the various features and that would activate them on the suit. So let's have a look at that custom app. So within the particle documentation under examples, we've got this rather useful example of controlling LEDs over the internet. So it shows one LED wired in there as well as the LED that's already on board, and it's got some example code which is actually the controlling an LED over the internet example, which is already in particle build. So I've already flashed my Photon with that code, which basically will turn both LEDs on and off, and that uses HTML post requests. So basically we can build an HTML page, and there's again example code right here. This is it. All you need to do is put that in a text file along with your device access token and device ID, which you can get from particle build, and I'm not going to show you what those are obviously, otherwise you'd be able to write an app that controls my Photon. Basically you can make this web page, which I've done just here. It's just one file on my C drive. When you open that, it opens in a browser and gives you the option to turn the LED on and off. And of course I can put this file anywhere on any device that's got a browser, view it in a browser, and then click on the buttons and that will turn the LED on and off. So I can use this piece of code to craft my own web page using an image of Hulkbuster to turn on and off the various features. So I've got that web page up on my laptop. I've just clicked on the turn the LED on radio button. We'll just come back over here and it should turn both LEDs on when I click on the do it button. Yes, there they are. Those are both on, and if I go back and click on turn the LED off, there we go, and that's of course controlled over the internet, which is great. That's just basically a piece of code which has a digital write, exactly the same as Arduino, that turns those LEDs on. So we could of course put any code in there that calls a function from any library or does anything. So we could turn on a whole string of Neopixels or do anything from any function. So basically this is a very simple example. We're only really scratching the surface there, and as I say, we could use this for the whole brains of a project. So I'm obviously really excited by this tiny board, and I'm sure you can see there's quite a lot of possibilities here. I can of course write a proper Android app that hooks into the Tinker API, and I could write a proper Android app that does post requests. There's also, as I say before, Node.js development platform, an iOS development platform, and lots of other stuff you can do with this for writing apps. It's just I'm not very good at app development, so I'm probably just going to build web pages with different pictures of schematics of Hulkbuster and little buttons where you can turn things on and off. Obviously that makes something quite portable that could be used on any device with a web browser. So that's all I'm going to do for now, but obviously I'm going to build the whole thing around this with all of the features and write code on this that potentially communicates with the other Arduinos using I2C and so on. So next time I'm going to be getting on with the actual suit and putting some more panels on, hoping to get these shoulders and the rest of the helmet built up and painted, and after that the forearms and the feet. At the moment I've only really done the front, but the back is pretty blank. But I need to exhibit this suit in October at DEF CON 4 in Southampton in the UK, so there'll be a video of that. So I really need to get it looking at least like it's finished from the front. So don't forget to subscribe to my channel if you haven't already for more updates on this project and other projects. Also check out my Patreon crowdfunding campaign at patreon.com/XRobots, where you can get access to some exclusive rewards, including a live broadcast with me. And don't forget to check out the rest of my projects, especially my R6 droid, which is entirely 3D printed.